Buckle up. This is a deep, technical, and boringly detailed walkthrough of the creation of a model like DeepSeek, from the first glimmer of an idea to a functioning, helpful AI. We'll break it down into major phases. Phase 1. The conception and strategy. This is the foundational, non-technical but critically important phase. Problem identification and vision. The why. The leadership at DeepSeek decides they want to build a state-of-the-art large language model. The motivation could be to advance the field of AI, create a commercial product, or serve as a foundational model for specific applications. They ask, what gap in the market can we fill? Do we want a generalist model like GPT, or one specialized in coding, science, or reasoning? The what, they define the core objectives. For DeepSeek, this was likely a highly capable, bilingual model with a strong focus on code generation and reasoning, available for both research and commercial use. They decide on the scale, a model with tens or hundreds of billions of parameters. Resource allocation and team building. Funding, securing hundreds of millions of dollars for computational costs, talent, and data licensing. Hiring, assembling a world-class team. This isn't just ML researchers. It includes ML researchers, the architects of the model, data engineers, to build the data pipeline, software engineers, to build the training and deployment infrastructure, infrastructure DevOps engineers, to manage the massive GPU clusters, product managers and linguists, to define use cases and ensure language quality. Architectural blueprint. Model architecture choice. The team decides on the fundamental neural network design. For DeepSeek, the choice was a decoder-only transformer architecture, which is the standard for modern LLMs like GPT. They finalize key details. Vocabulary size, e.g., 100,000 to 250,000 tokens. This requires building a custom tokenizer. Model scale, e.g., we will build a 67B parameter model and a 7B parameter model. Precision, using float 16 for training to save memory without losing too much precision. Attention mechanism, they might decide to use techniques like grouped query attention to improve inference speed. Phase 2. Data curation. This is one of the most critical and labor-intensive steps. Garbage in, garbage out. Massive web crawl. The process. They run web crawlers for months, scraping terabytes of text from the public internet. This includes forums, news articles, blogs, and websites from all over the world, with a specific focus on Chinese and English sources. The boring detail. This results in a raw dataset of tens of terabytes, filled with duplicates, low-quality text, spam, and potentially harmful content. Data deduplication. Why? Training on duplicate data is inefficient and can hurt model performance. The boring detail. They use algorithms to find near-duplicate documents at scale. This might be done on massive Spark clusters, processing petabytes of data to shave off 5 to 10% of the dataset. Quality filtering. How? They train a classifier model to predict if a document is high quality. The training data for this classifier is created by humans rating thousands of text samples based on criteria like coherence, grammar, and informativeness. The boring detail. Every single document in the tens of terabytes dataset is scored by this classifier. Only the top scoring fraction is kept. This is an enormous computational task in itself. Toxic and sensitive content filtering. How? Another classifier is trained to identify and remove content that is violent, hateful, sexually explicit, or contains personal information. The boring detail. This is an imperfect process. The team has to carefully tune the threshold to avoid being overly aggressive or too lenient. Code data curation. Special treatment. Since DeepSeek has a coding focus, they create a separate, high-quality dataset from public code repositories. The boring detail: they don't just take raw code. They filter by license, deduplicate, and might even use tools to analyze code quality.